All right, here we go. Now, so first one we filled in were the 90-degree increments. So let's do that. We're going to fill in the degrees first. So let's start. I am not looking at you. 0 degrees. Do you guys agree? And we go to the top and we're going to fill in what? 90. And we're going to make this neat and nice and beautiful. Neat, nice, and beautiful. We're starting a new one. Okay? Pardon me? No, just hold on. Just hold on. Let's do this first. With a pencil. That's fine, or a pen, whatever. All right, so 90 degrees. What's this one over here? 1/2 of a revolution is 180. Guys, you got to hang in here with me, and I am recording this today. Yesterday's video recording didn't record. I did too until this morning. I looked and tried to run the recording, and it didn't record at all. Cried. Not really. What's 180? 180, what's next? 180 plus 90 is 270. Even if I don't know that by heart, I'm going to take 180 and I'm going to add 90-degree increments. 270 plus 90 is 360. Now, we got to go back and we got to take care of our radians. All right, so here we go again. 0 radians, back around. 1/2 of a revolution over here is going to be how many radians? Pi radians. 1 pi. So half of that will be pi over 2 radians. Pi over 2 radians. So we're going by 1/2. 1/2. Halves. 1/2, 2 halves. What's this one down here? 3 halves. 4 halves, which is actually, bless you, just 2 pi. Okay? Now, you got to think. Halves. 1/2, 2 halves, 3 halves, 4 halves. Now, are we done? No, because we got to go back and we got to fill in the terminal points, the ordered pairs. The ordered pair for 0 radians is 1, 0. Be sure you remember we go right 1 and we don't move up or down any. When we go to 90 degrees, what's that ordered pair, everybody? 0, 1. 180 degrees is -1, 0. And down here at 270, it is 0, -1. Everybody in this room, even my Sarahs, both ought to have that, okay? Oh, and Sarah was in my most forgiving trig class ever. She was. Bless your heart. She's on the wall. That first semester I taught trig, it was horrible. But you're on the wall because you're my niece. It was awful. I sucked so bad. It was terrible, and they were so kind to me. They may have talked about me so badly when they left the room, but they were so sweet and kind to me while they were in my face. Thank you, Sarah Joyce. Now you'll be on YouTube forever. Now, because everybody watches these videos. Not. All right, so now we're dealing with 90-degree angles. Now what's half of 90? 45-degree increments. So we got to think 45-degree increments. So go with your highlighter or your marker. And we are going halfway. Halfway. Just hold tight a second. You use the same color for your 45-degree angles. That's why you're using a straight edge. Okay? Now, so I've got my 45-degree angles, my line. Now, what does that allow Miss Perry to do? Because y'all know I can't have too much. It throws me off. Now I'm able just to focus on my 45-degree increments, okay? Now I know that's where I'm going. So I'm going to go with my red this time, changing colors. What increment? 45 degrees. So we're going to go around and we're going to count off by 45s. 45 degrees, 45 plus 45 is 90. It's already there. 90 plus 45 is 135. Thank you. 135 plus 40 is 180. 180 plus 45 is 225. Of course, we're going over the degree measures. 225 degrees plus 45 is 270. 270 plus 45 is 315. If you need another one, get another one. Okay? It's all good. Go on. 315 plus 45 is 360. We got our degrees in, right? Okay. Remember, I'm recording. It's all good. Now, got my degrees. Now we got to think what? Go back to, we got to think about radians. All right, so just a special note. If you forget, half of multiplication translates into of, or of translates into multiplication. 1/2 of pi over 2 gives us which angles? Pi over 4. Again, you never have to memorize anything. We are mathematically coming up with this stuff. So 45 degrees is equivalent to pi over 4 radians. Do you guys agree? Good. Your silence is everything. Now we're counting off by what? Fourths. All right, here we go. 1/4 pi. 2/4 pi. Oh, that reduces to pi over 2. We're good. That was 2/4. This is going to be 3/4. Keep going, and now we have 4/4. Oh, it reduces. Bless you. All right, so we're at 4/4. All right, we're ready? 4/4, and now what? 5/4. Got the squeakiest shoes ever. 5/4, 6/4. Oh, wait, it reduces to 3 pi over 2. That's 6. What's the next one? 7/4. 7 pi over 4. And then up to 8/4, which reduces to 2 pi. You with me so far? Okay. Now, here we go. We've got to go back to ordered pairs. This is the easiest part for these angles. Why is this easy for the pi over 4 angles? The ordered pairs, it's the same value, isn't it? Why is it the same value? Why is the x-coordinate the same as the y-coordinate? What's it go back to? The parent graph. What's the equation for the parent graph? Y equals x. The values are the same. So what are the values? Root 2 over 2. Root 2 over 2. You jump back to the yellow line. Boom. I know it's the same, but what do I have to be mindful of? The signs. Every time I move into a different quadrant, my signs change. Don't forget that. Okay? And then move back to the yellow line. That's why I colored them in, y'all. It's going to be negative root 2 over 2, negative root 2 over 2. Okay? Jump into the fourth quadrant. And it's going to be positive root 2 over 2. That's in the wrong place. Root 2 over 2, negative root 2 over 2. Do you guys agree with that? Okay? Everybody good? Yes? Okay. Please give me a nod or a go. Move on. All right? Am I done with the 45-degree angles? Okay. Breathe. Where next? Where did we go to next yesterday? 60. We started with the big, and then we whittle our way back to the smaller angles, right? And Cindy, this is going to be strange for you because this is like brand new. All right, so get out your other marker. We got to go to 60. If you remember, are we talking the skinny X or the short and fluffy X? Skinny, because it's got to be greater than 45 degrees. So check this out. Highlight. Got to talk my way through this. Yeah, let's go with that. Tall and skinny. There she is. Tall and skinny. Ooh. Yes, thank goodness. All right, so now I'm focusing on the green line. Shut up, don't be hating on my line. I know. That's why you do with your straight edges. Straight edges. All right, here we go. Green. Look at how color coordinated this is. All right, so now. All right, so breathe. Here we go. This is the what angle increments? 60-degree increments, okay? So let's go up here. And here's the thing, folks. Doesn't the 60-degree angle have to be bigger than 45? Okay, so that's common sense. Okay, don't get all tangled up in all these numbers. 60 degrees. We're going to add 60-degree increments. 60 plus 60 is 120. Go to the next green line. 60 plus 120 is what? The what? 120 plus 60 is 180. Takes me to that x-axis. 180 plus 60 is 240. That takes me to that next green line. And then think 240 plus 60 is 300. 300 plus 60 is 360. Okay, so we've made our one round with our 60-degree increments. You with me? Okay. Now, we go from degrees to what? Radians. Okay. Think. Y'all, what's going to be between a half and a fourth? A third. Okay. Pi over 3. And now we're thinking thirds. So count this off in thirds. We got 1/3. Go to the green line, and we have 2/3. 2 pi over 3. Go to the x-axis, and we have 3/3. Oh, that's just pi. What's my next radian measure? We got 3/3. Now we've got 4/3. Good. Go to the next green line, and we've got 5/3. 5/3 goes to 6/3, which is 2 pi, right? Okay. Now, order pairs. This one you may have to look back on. If you watch me closely over the next week, 2 weeks, okay, you're going to see me do this a lot, and you can't see this on the recording, but you will see me go, oh, 1/2 √3 over 2. And I will do that every single time. It does not matter where my coordinate is. Doesn't matter which quadrant that it lies. I'm still going to come over here to quadrant 1 and go boom, boom, 1. You'll see in just a minute. Hold that thought. I'll away the key just a second. Well, just put it in your pocket. We'll get it in a minute. All right, 1/2. Folks, is this ordered pair going to change at any of the 60-degree, at any of my green lines? No. The only thing that's going to change are my what? Are my signs, depending upon the quadrant in which it lies. So, come back over here to green. We got -1/2 √3 over 2. Okay? Go down to the next green line. And we're going to have negative. See, I had to do it again. -1/2 √3 over 2. I do not know these. I only know the first quadrant. But I know I can do something to figure it out. And then, come over here to the bottom of the green. And we're going to have +1/2 -√3 over 2. Y'all cool so far? This is a lot to take in, okay? Everybody good? If you're not, I expect to see you when? In the morning, okay? Now, are we done with the 60-degree increments? Yes. Draw your other line. Highlight it in, whatever. Mark it up. All right, so focus on my blue line. Now we are dealing with what increments? We started with 90, we dropped back to 45. Now we're dealing with 60, we're dropping back to 30, half, 30 degrees. Now, folks, just go around your unit circle and add 30, and it will take you to the right place. 30 plus 30 is 60. Yep. 60 plus 30 is 90. Yep. Oh, I feel like that guy on that. Oh, don't do that. 90 plus 30 is 120. Y'all know the guy I'm talking about? Yep. I can't stand him. I would want to punch him in his face if I was at an auction with him. Yep. Sorry, fella, because I know you watch this video. 120 plus 30 is 150. What's his name? Dave. Yes. I don't care. He's not going to watch this video anyway. 150. Yep. 150 plus 30 is 180. 180 plus 30 is 210. Throw that one in. 210 plus 30 is 240. 240 plus 30 is 270. 270 plus 30 is 300. 300 plus 30 is 330. Okay? 330 plus 30 is 360. Okay, we got our degree measures in. Now what? Radians. Okay. Now, if you are unsure of what to do, check this out. 2, 3, 4. It's going to be 6. Don't put 5. Don't do 5. But if you're not sure, we want to find 1/2 of what radian measure? Pi over 3. What's 1/2 of the 60 degree? What's 1/2 of pi over 3? Pi over 6. Okay? So we got pi over 6. So now we're thinking in terms of what? Sixths. That's hard to say. It is hard to say. Sixths. 1/6. 2/6 is just 1/3. 3/6 is just 1/2. 3/6. 4/6 is just 2/3. That was 4. This one has to be 5/6. And then 5/6 is 6/6, which is pi. You guys with me? Okay. That's 6 over 6. What's the next one? 7 pi over 6. 8 pi over 6. Oh, wait. It's 4 pi over 3. That was 8 over 6. 9 over 6, which is here. 10 over 6, which is here at 5 pi over 3. And then 11 pi over 6. Okay? 12 pi over 6 is 2 pi. Do you guys agree with that? Okay? Somebody pass Tiffany an extra unit circle. Just pass one over to her. Okay? Now, order pairs. Okay? Do we have to learn anything new for this ordered pair? No. We have to take the 60-degree ordered pair and do what with it? Flip it around. Switch those values. So this is going to be root 3 over 2, 1/2. And guys, this is why you're going to see me. You know, earlier when I went, you saw me go, 1. Do you notice the pattern? This was that last question. 3, 2, 1. Oh, yes, look. Check this out. 3, 2, 1, and then it goes back around. 3, 2, 1. Check, watch. 3, 2, 1, 3, 2, 1. Am I memorizing anything? No, not other than 3, 2, 1. That's all I'm memorizing is 3, 2, 1. 3, 2, 1, 3, 2, 1. And you guys will see me do that 100 times in the next 2 weeks. 3, 2, 1. And then come back over here to the other blue. This root 3 over 2 is going to be negative root 3 over 2, positive 1/2. This one's going to be negative, negative. This one's going to be positive, negative. Now, that's a lot, isn't it? But what do I only want you to focus on? 3, 2, 1, 3, 2, 1. And I only want you to learn which quadrant. You only have to know the first one, because if you know the first one, you know the other ones. Okay? Let's fill in a little bit more information here, just because this is what you're going to have to do. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. You're going to have to do that. Okay? You're going to have to fill in Q1 tomorrow. Yeah? Yep. We ain't wasting any time. You also need to know your signs. Positive, positive. Negative, positive. Negative, negative. Positive, negative. Throw your signs in there as well. Okay? So you got to know the whole thing. And I'm going to tell you what. The quicker you learn this, the better off you will be. I heard this morning that pre-calculus, you have to know this. You have to know this. Have to. You don't have an option. Don't roll up in here with things drawn in your calculator. Been there, done that. Don't do it. Don't come in here with your little note under your form. Did you notice anything else about everything else? Remember those 2 questions I gave you at the end of class? I said, what do you notice about? And then you figured it out. 3, 2, 1, 3, 2, 1. That was the one thing I wanted you to recognize. But there's something else. And I want to go to my original. This is my end all and be all of my unit circle. Anybody notice anything else? Why do I keep saying you just have to know the first quadrant? What do you see? Do you see anything? Say it again. The 3, 4, and 6. So you're seeing other patterns. 2, 3, 4, and 6. On the other side. Oh, 2, 3, 4. Hold on, that's the same thing on the right side. 3, 4, 6. 3, 4, 6. Huh. The yellow line has a 3. This yellow line has a 3. Look at the bottom. The bottom yellow line has a 3. What am I looking at, y'all? I'm looking for a big old geometrical term. Yes, thank you very much. This is symmetrical, folks. If you were to take this unit circle and you were to fold it, hot dog, remember that from elementary school? If you were to take it and fold it, my blue lines would match, wouldn't they? That's why I said you don't have to know anything but the first quadrant, because watch. Hook up these blue lines, and you got a pi over 6 and a pi over 6. You've got a root 3 over 2, 1/2. You've got a root 3 over 2, 1/2. But what changes? The signs. Does it go this way too? Heck yes. And does it go this way too? Yeah. And look, now we've got a rectangle that connects all my pi over 6 angles. I can do the same thing for the pi over 4 angles that go together. And this is going to make me insane, but I'm going to do it anyway. Here and here, here and here, here and here. I am. Green. Isn't that crazy? It hurts my eyes too. But it really does. That's why I'm walking away, because I can't stand up there close and look at it. But do you see how they're all connected? That's why over the next several days, what will you have at your disposal? Markers, straight edges. Okay? I am challenging you not to be tempted to do something you ought not do. Like cheat on this quiz. Because we've had people do it. Don't do it. You're never going to learn it if you do. You have to learn it. Okay? I expect, if you do not get this, I expect to see you in here tomorrow. I expect you to go and watch this video tonight. That's what I expect of you. Okay? I expect you to put something, unit circle, learning the unit circle values into YouTube and find another video. Because I don't think mine's the bomb by any means. There's something out there, and if you find one better, you better share it with me. Because then I'm going to steal their ideas and play it off like they all mine. That's what all good teachers do. Never reinvent the wheel, folks. No use. Okay? Now, you feel like you run a marathon? Because I do. Okay? Take a break. Suck it up and do your job. Here we go. All right, you got to learn. What's tomorrow? Quadrant 1. Be ready. So when you come into class tomorrow, go on and get your straight edge, go on and get your markers, and be done with it, okay? Get my planner. Yeah, get my planner. I'm going to roll on, though, okay? Just that little chunk in the top right-hand corner. That's it. You got this. I don't care what kind of ball games we got. You got this. Love you. Okay, here we go. So, we're going to do this without the unit circle. We're going to draw some more angles. And we're going to determine the terminal points. Hey, if you weren't here yesterday, you got to get the notes from yesterday. You always have to do that, okay? Here we go. All right. I didn't leave her. Here we go. We didn't leave you. Okay, I just want you to know. All right, class. 4 pi over 3. Hey, we got to think. Thirds. What increment? Think degrees. What increment are we dealing with? Pi over 3, where is it? It's up here, so that's your 60 degrees. That's what we're thinking, 60-degree increments, all right? We've got to draw this thing. And then what kind of, I've got to prepare my graph with what kind of x? Skinny one. And I have to prepare my graph how? For me. I got to do one more thing to this. Take out the y-axis. I have to do that. I personally have to do that, okay? Well, I'm not even drawing them in there. That's why if they're not there, I don't think about them. Because now I'm only focused on the 60-degree increments, okay? I'm only focused on the pi over 3 angles. So I don't even draw them in there. I don't want them in there, okay? Now watch. You already know rotating up or down. Rotating up, and I'm going to count this off by 4s. Not by 4s. I'm going to count 2, 4. Sorry. So I've got 1, 2, 3, 4. Guys, did we agree? Do you agree with me? We're going to end up in quadrant 3. Okay? I want you to put that because that's going to help us. Quadrant 3. Now, here's what you're going to see me do 400 times. Watch this. I'm not using my unit circle that we just filled out, and you don't need to either. It's a pi over 3 angle. That means in my head, I'm going to go 3, 2, 1. What is that ordered pair up here? 1/2 root 3 over 2. I'm going to follow the line, and what's that ordered pair right there going to be? Negative 1/2, negative root 3 over 2. I use this as my guide. I follow the road. Boom, I change my signs. Let me say that again. I just made that up. I bet I won't be able to say it again. Dang it. 3, 2, 1. I write that ordered pair. I use it as my guide. I follow the road. I change my signs. Isn't that what I did? Okay. Did I learn that third quadrant ordered pair? No, it all come from the first quadrant. Okay. Let's do another one. Okay, let's look at another one. Figure out what increment we're dealing with. Negative 5 pi over 3. I'm still in the land of what increments? 60, okay? I need to write that to the side for me. 60-degree increments. Now, draw your axes. Prepare your graph with which x? Skinny. And I have to get rid of my y-axis for me. Because remember, if it's a 60-degree angle, then I have to have 6 slices of pie. How do I know that? 360 divided by 60 is 6. Okay? Now, I'm rotating up or down. Rotating down. And we got to count to 5. So here we go. 1, 2, 3, 4, 5. Oh, thank God. I don't have to move anything, do I? Yes. Ah, okay, here we go again. Watch what I do. I know it's up here at the top, so it's going to be 3, 2, 1. What's my ordered pair? 1/2. 3, 2, 1, 3. Root 3 over 2. Are my signs correct? Yes, because I'm in which quadrant? In the first quadrant. So that's Q1. You guys agree? How you feeling? Yes? All I do is I count my lines. Okay, and then you know it's based upon the number in my numerator. All right, so I go 1, 2, 3, 4, 5. And that's where I stop. Okay, you cool? All right, you understand how I got my 4 over here? 1, 2, 3, 4. The order pair? Yeah. That one. That is in my head. I am seeing the first quadrant. And if you look at your unit circle, remember it starts down here with the 30-degree angle, and it starts 3, 2, 1. That's what I lock into, and I write my 1/2, and I know my other one has to be root 3 over 2. 3, 2, 1. But y'all will see me do that a bunch. Okay? And if you'll just get into the habit of, you got to know it. You've got to know that first quadrant. Okay? 3, 2, 1, 3, 2, 1. The light bulb. All right? Questions? Let's do another one. Let's do this one. Question, did I see a hand? No. All right. How about this one? Okay, we're changing gears. Changing gears. 5 pi over 6. What kind of increments? 30-degree increments this time. Because you just have to know. If you'd have been here, because that first quadrant, if it's that pi over 6 angle, that's going to be the first one we come to, Tiffany. Oh. Okay? So I'm thinking 30-degree increments. How do I prepare my graph? Skinny and short, right? And it looks like a hot mess, and it's going to drive some of you crazy. These drive me crazy, okay? But I cannot rotate these angles and draw them unless I have my little guides there, okay? 5 pi over 6. Is it rotating up or down? Not for this one. Why? Because I have to, if I'm in 30-degree increments, Jansen, it's going to be 30, 60, 90. See, I've got to have that one there, okay? The only time I take out that y-axis is when I'm dealing with those 60-degree angles. The pi over 3 angles. That's the only time. Yes?
Why do you have that go to the increment?
Because I've got to show the 30, 60, 90 progression. Okay? So look, one more time. 30, 60, 90. Okay? Pi over 6, 2 pi over 6, 3 pi over 6. Yes? That's a good question, though. How do you know which guides, which X's to put in your picture? How do I know that? What's it based upon? How do I know which X to draw? How do I know that? It's the denominator, right? The denominator is what tells me which X to draw. And if you go back and you look at the end of your notes yesterday, didn't I put review? Pi over 4 angles, perfect X. Pi over 3 angles, 60 degrees, skinny. Mark out the Y. If you go back and look in your notes, it's in your notes, okay? And you've got to know that. 30-degree increments, 5 pi over 6. I'm going to rotate up, and I'm going to count to 5, because that's my numerator. 1, 2, 3, 4, 5. And now what? Okay, here we go. 3, 2, 1. So this is going to come over here, won't it? Don't they match up together? Yes. So my ordered pair over here is going to be 3, root 3 over 2, 1/2. And if that's my ordered pair over there, then what's my ordered pair over here? Negative root 3 over 2, positive 1 over 2. Do you guys agree with that? Okay? Yep. On your quiz tomorrow, though, what are we only concerned about? First quadrant. Got to know just the first quadrant tomorrow. On Friday, first 2. Monday, first 3. Tuesday, whole thing. Probably Wednesday, whole thing again. All quizzes. They count once. But you have the potential to rack up 5 100s by next Tuesday. Where's that 5th 100 come into play? Progress report. I'm going to give them out on Monday. You have them signed, return them on Tuesday. You get another 100. Okay? I'm trying to help you out. Okay? Trying to help you. Which quadrant did we land in? Quadrant 2. Okay? All right, here's another one. Here's another one. Negative 5 pi over 6. Let's change that and let's go negative 11 pi over 6. Negative 11 pi over 6. You do that one. All right. We ready? Negative 11 pi over 6. I'm still dealing in the 30-degree increments, right? Okay. I got to prepare my graph with skinny and fluffy. Okay. Gotta love fluffy. More to love. Here we go. Rotating up or down? Rotating down. And I've got to count to 11. All right, here we go. Where do you know it's going to be? It's going to be 1 away from what? 12. Okay, if you need to count it by ones, then count it by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, first quadrant. Whoop, whoop. First quadrant, that's nice because I don't have to reflect anything, do I? All right, 30-degree increments. What's my first one that you're going to see me go? Boom, boom, boom. Root 3 over 2. 1/2. Are my signs correct? How many of you got that? High five, y'all. Good God. Good God. Good guys, good girls, good God. Maybe that's what I'll say. Good class. Meaning all y'all. Out of y'all, that's what I'm going to say. Out of y'all, here we go. Questions. Are we feeling better? Yeah? Some of you gave me a definite, yep, I'm feeling better. Here's another one. Out of y'all. Here, I want you to do these two, okay? We'll make you cry. You're welcome. 15 pi over 6 and -3 pi over 4. Focus, Kaylee. Here we go. All right, 15 pi over 6. Did you guys immediately jump on 30-degree increments? How many of you jumped on 30-degree increments? Bring it on. Bring it on, 30-degree increments. Okay, hold on. I did. How many of us jumped on 30-degree increments for this problem? Why? Because of the 6 in the denominator. However, I got a little something to show you here in a minute. You better pay attention. Don't you miss this. How am I going to prepare my graph? Don't. There we go. That is such a mean word. I can deal with somebody saying, you are fluffy. Yes, I am. But if somebody said, you fat, I'm going to smack them. Because that's just not a nice word. I can deal with fluffy, but not fat. Like I don't see what you see. Come on now. I'm talking about this too. Let's get back to trig. Let's get back to trig. Here, that's a life lesson number 124. Gentlemen, 125. Life lesson. Time out. Life lesson number 125. Ladies and gentlemen. Gentlemen always say nothing. Gentle ladies, I don't wish that on anybody, but I'm just saying, you would a whole lot rather be considered fluffy than fat. Okay? Gentlemen, you just don't say anything. You just say, yes, baby, beautiful. You are gorgeous. I don't care if I can't get my arms around you. You're beautiful. I know. Here we go. Come here. Oh, that's a good hug. Just think. All right, here we go. Stop it. Y'all are not good. All right, are we rotating up or down? Jeez Louise. See, y'all are bad. It's y'all's fault. Y'all are the devil. Devil. Am I rotating up or down? Focus. Up, counting to 15. Oh, my Lord. All right, one whole revolution is going to be how many? 12. 12, 13, 14, 15. What? Hold up. That's a nice one to end on, isn't it, ladies? Peace out. Sorry. Huh? Look at that. What happened? How did I end up on an axis? How did I end up on an axis? I could have reduced it. 15 over 6 reduces to 3 over 2. 5 over 2. It reduces by 3s, and we should get 5 over 2, right? Okay? Now look. 1, 2, 3, 4, 5. Yep, 5 over 2. What's the ordered pair? This one's a piece of cake. I'm on the y-axis. It's 0, 1. It's 0, 1. It's yours, man. That's the one you knew. That's the one you knew before you walked in the door. Now, which quadrant? It's not in a quadrant. It is on the y-axis, and that's what you need to put. On the y-axis. It is not in a quadrant, y'all. It's not in one. I said y'all again. 5 pi over 2. Can you reduce them? Yes, you still end up with the same thing, okay? A dollar bill is still a dollar. 4 quarters is still a dollar. It's all the same value. It looks different. 3/4. How many of you had example 5 correct, by the way? Hands up. High five. At a class. Oh, we got something going on here, Tiffany. What's going on here with this one? It's a 4. Ding, 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 ding. What kind of X do I draw for this one? Perfect X. Okay. We haven't done these today, have we? These are what kind of increments? 45. All right. Am I rotating up or down? Shh. Down. Shh. 1, 2, 3. What quadrant? Q3. And that's the easy ordered pair. What is it? There we go. That one's easy. That one's easy. Because that's the one that repeats. That's a no-brainer. You want a test or a quiz full of pi/4 angles, right? That's like, yes. I don't have to do anything because they're all the same, right? Pi/2 angles. Questions on that?
So we don't have to fix it for...
You know how I know because it's a 45-degree increment?
Yeah.
I'm locked in automatically. Stop talking because you're being rude. I already know that it's root 2 over 2, root 2 over 2. I already know that. So I don't have to go for that one, 3, 2, 1. I could, but I don't have to.
But do you have to write it on the others?
No.
Oh.
No, because all you're concerned about doing right now is drawing that angle, listing the quadrant, listing the terminal point. That's it. Okay? Good question. Any other questions? I'm going to make you cry. Everybody say, thank you, Easter. Okay. All right, here we go. I'm all right with this. Shut your face, man. All right. What do we do with the 9? What the world? Guys, this is all about fractions. Fractions. Let's think about that. I do not know a special angle with a 9 in the denominator, do I? But, am I going to rotate up or down? I'm going to rotate up. That doesn't change. Half of a revolution would be 1 pi, correct? All right, let's translate it into ninths. What would it be? 9/9. Write this down. And then 1 complete revolution would be what? 18/9. We've got to think in terms of ninths. Now, just for the sake of saying, what would halfway? Nope. What would halfway be? 4.5. How'd you get 4.5? Because it's half a 9. And then, what would this one down here be? What would we add to 9/9? It'd be 13.5 ninths. Because 9 plus 4.5 is 13.5, okay? Now, how do we graph it? We just draw the spiral, folks. And we end up in the quadrant where we need to end up. No, watch. That's where it's going to be, right? It's going to land in the first quadrant. Do you guys agree? Because 19 is 1 past 18, yes? All you need to do is draw the angle, write the quadrant, you're done. We don't have anything at our disposal right now to be able to find that terminal point. And quite frankly, we don't care. You can learn that later. All we care about are special angles, okay? You do this one. You do this one. Is everybody with me? You understand how we're getting these numbers? Oh, this one's so easy. Good gosh. I shouldn't even assign it. I shouldn't even throw it up here. Stupid. You don't have to do anything. What's that going to be? Which quadrant? Or try again.
This will be
Yeah.
So it's like the 15 and the 9.
Yeah. Rotating up or down? Up. We got to focus on 15ths, right? So this would be 0. Half of a revolution would be 15 15ths. Do I need to go any farther? No, because my angle's going to end up here. I don't care if it's accurate just as long as the angle is kind of close to 15 15ths, right? And we put Q2. Right on? That's easy. That didn't get difficult, did it? Smarty britches. Here's another one. Oh yeah, last one. Graph it. Just for the sake of this problem, are we rotating up or down? Okay, we're rotating down for this one. And let's just say that we do not see that we can do what to this fraction? We don't see that we can reduce this. We don't see it. So we start graphing, and we're thinking in terms of 12ths, right? Okay? So I'm rotating down. So when I come down here, that's going to be 12 12ths. Do you guys agree with me? And when I complete that downward revolution, up here above my 0 will be 1 complete revolution, which will be, there we go, 24 12ths. But I'm still not there. Now, how would I know what would fall here? Somebody said it. 6. Why are you choosing 6? Because it's half a 12. So if I were to go here, that would be 6 12ths, right? If I start that revolution again, 6 12ths, 12 12ths, what was this one be? 18 12ths, 24 12ths, and then if I went on around, it would be what? What would be your next value? 30 12ths. Okay, now look, what have I done? I've gone around, that's 2 pi, and now I have to go a piece to 27, don't I? Because what if I chose 33? You'd have to know to go beyond 30, wouldn't I? Yes, you would have to know that. Now, what quadrant? 4th. We're done. That's it. Okay? I'm going to leave that up there. And I am also going to put your homework up here. Hey, guys, check this out. Don't forget, tomorrow you have to know the first quadrant in your unit circle. That's the first thing we're going to do. And it won't be any, let's review. You better come in here. Bell rings. You're in your seats. You get your markers and stuff before. I give you a paper. You do it. You turn it in. That'll be like a 10-minute quiz. That's it. Okay? 15 minutes tops. In addition to studying, I want you to do page 120, 15 through 19, 21, 22, 25B through D. You're doing the same thing we've been doing. Draw the angle, find the terminal point, okay? Easy. By doing this homework, hopefully it will help you on your unit circle, bless you. Everybody working. Everybody working.